All right, for this last example here, we are going to multiply together complex numbers. And with multiplying complex numbers, you're gonna either see examples like this, where you are simply just distributing a term to a complex number, or the second problem, where you have to FOIL, because these are two binomials. So the key here is remembering what we talked about in the very first video. So I, if you remember, is equal to the square root of -1. And I squared, remember we showed that if you square the square root of -1, the radical goes away and you're left with I squared equals -1. This is important to remember when you're multiplying complex numbers, because most of the times you're going to end up with a term that has I squared in it, and you don't leave it written as I squared. You're going to replace that when you simplify with -1. So that's the first thing to remember as you're doing these, that when you get to the end and you have an I squared, you're going to simplify. So let's go ahead and walk through this first example. So in A, we've just got 4i, and we're multiplying it times -6 plus I. So in this one, you're simply going to distribute 4i to both terms in here. You're going to multiply it by -6 and times positive I. And then you're going to simplify your complex number. So let's look at what that we end up with. -6 times 4i is -24i, plus 4i times I is just 4i squared. Okay? That's our first step. Now, remember, I squared we want to replace with -1. Okay, so we're going to replace, wherever you have I squared, replace it with parentheses and -1. The parentheses are important to keep track of your negative, because now we're going to have to multiply this by our term. Okay, so all we're doing in this step is replacing I squared with -1. Now, we get 4 times -1 is -4, and we have -24i. We write it in standard form, which always has the real part first and the imaginary part second. So -4 minus 24i would be our solution. So we take the -4 we get from multiplying 4 times I squared, that becomes our first term, and minus 24i. So that's how we multiply a single term times a complex number. Now, when we multiply two complex numbers together that are both two terms, we have to FOIL. Now, if you remember, it might have been a little while since you FOILed. FOILing, we have to multiply each term by each term in the other set of parentheses. So FOIL stands for first, outer, inner, last. And this is the order in which you multiply your terms out. So first means that we take 9, which is our first term in our first binomial, and multiply it by -4, the first term in our second binomial. That's our F for FOIL. That's first. When we do that, we get -36. Outer means that we take the outer terms in each. We take our outside and outside. These are the ones on the outside of the parentheses. So here, we're taking 9 and 7i and multiplying them together. That's our outer. Okay? Here we get plus 63i. 9 times 7i is 63i. I, inner, so we take -2i and -4, multiply them together to get 8i. That's the I in FOIL. And then last means the last term of each binomial. So here we take -2i and positive 7i and multiply them together. So we get -14i squared. So we did first, outer, inner, last. Okay, that's how we multiply. You've all done this in Algebra 1, so this is just a review. And we get -14i squared. Okay, now it's just a matter of combining like terms. So here we've got -36, 63i plus 8 is going to get 71i. Now remember, I squared. We're going to replace this with -1. So we're going to end up with minus 14 times -1. So we're actually going to have -36 plus 14 for our real part. So -36 plus 14, we're going to get -22 plus 71i. So key here is you FOIL, don't forget any terms. You have to go through and multiply. You should end up with 4 terms that you need to combine the imaginary part, replace I squared with -1, and then combine your real parts, and then write it in standard form. Go ahead and give 11, 12, and 13 a shot right now. Go ahead and multiply those out, and then write your answers in standard form in the text box that pops up now.